Alright, time for a fun little thing called the product rule, which is a different way to do derivatives that you might have to use if two things are being multiplied together. So in the case of this y right here, under the example, y is equal to the x squared minus 3x times x. And for context, this is the equation. The derivative of y is equal to the derivative of the first term times the second term plus the derivative of the first term times the derivative of the second term. So I'll show you what I mean by this. So if y is equal to x squared minus 3x times x, then I can break this down into two different things. So I'm going to say f of x, my first term, is x squared minus 3x. And the derivative of that is pretty simple. F prime of x is equal to 2x minus 3. This is my second term. I'm actually going to highlight it in red. And this I'm going to call g of x. It doesn't actually matter what you call it. All that matters is that you know what it means. And that's x, and the derivative of x is 1. Now you have to memorize this formula because it will never be given to you in math. I'm going to use orange. Why not? So y prime is equal to f of x times g prime of x plus g of x times f prime of x. It's a pretty simple formula because you have both of them as derivatives and then both of them as normal functions, and they're just being added together. It doesn't matter the order at all. So y prime, now I'm going to plug in my f of x is x squared minus 3x. My g prime of x is 1, so that's times 1, plus g of x, which is here, it's x, times f prime of x, which is 2x minus 3. Now I can just multiply these out, so x squared minus 3x times 1, of course, it's just x squared minus 3x, plus x times 2x minus 3 is 2x squared minus 3x. So y prime then becomes equal to, these two are like, actually I'm going to change colors. This is a like term with this one. So this becomes x squared plus 2x is 3x squared. And then these two are like terms, and they're both minus 3x. So that becomes minus 6x. And that is my, I'm going to rewrite it actually one more time, just because that's a weird color. And this is my derivative. All right. Now, for this next one, this model problem, this one is different because it doesn't give you a function. All you know is that p of x is equal to g of x times h of x. So the first thing you should think whenever you see two functions multiplied together is product rule, because a product is two things multiplied together. Again, this time before I go into it, you can pause this video and try to do it on your own first, but start by writing out the actual equation for the product rule. All right, so this is our equation for the product rule. But it's asking for the tangent line, the equation of the tangent line at 4, which means I need to do two things. The first thing I need for an equation is a point And the second thing I need is a slope. So to find a point, that's probably the easiest part. All I need to do is plug in 4 to my original p. So p of 4 is equal to g of 4 multiplied by h of 4. So p of 4 is equal to, and it looks like my g of, at x equals 4, my g of x is 3, multiplied by my h of x, so my h of 4 is -1, and I got -3. So my point for this would be 4, comma, -3. This is my x value, and this is my y value when I plugged it into the original function, not the derivative. All right, now going back, this derivatives again, derivative is the slope of the tangent line. So p prime of x is equal to g of x times h prime of x plus h of x times g prime of x. Sounds complicated. Let's just go ahead and plug it in. So g prime of 4 is equal to g of 4 times h prime of 4 plus, that's actually really ugly, so I'm going to erase all of this. G of 4 plus 8. And I can't even follow my own equation. H prime of 4 plus h of 4 times g prime of 4. Last thing I got to do is substitute in for the table. So g of 4 is 3. Use different colors here. 3 times h prime of 4 is 4 plus h at 4 is -1 times g prime of 4, which is -2. Simplifying, this becomes 12 plus -1 times -2 is 2. So this becomes 12 plus 2 equals 14. Now remember, this is not my answer. This is my slope. So now I have a point and I have a slope, and I can put this into point-slope form pretty easily. All I got to do is say y, I need that to be thicker, y minus y1 is equal to m times x minus x1. So y minus my y value is -3, so that becomes minus -3, so I'm going to say plus 3 is equal to 14 times x minus 4, which is my x value. That's why we use point slope form, is because it is pretty easy to use. You just look at your points, look at your slope, and put it right in there. You don't have to do anything else other than that. The other one I want you to think about, you're going to do problems 1, you're not going to do problem 2, but you are going to do problems 3 and 4. And 4, it doesn't give you a table. It gives, like I just did, it gives you a graph. But remember, let's say I wanted to find, this is of f of x. If you want to find f of, let's just say, what it actually is about, of -1, obviously you would just look at this and go at -1, f is 3. What about f prime of -1? Remember, a derivative is just the slope at that point, which is also the slope of the tangent line. So at -1, which is right here, my slope, I can go like this and say this is my rise of -1, it went down 1 over 2, so my slope is -1/2. at f prime of -1. So just because it doesn't give you an explicit value, you can still find the slope sometimes by using basic y2 minus y1 over x2 minus x1, which is the change in y over the change in x between 2 points